Good morning. This is the meeting of the Marine and Freshwater Quality Committee. It is January 24th. I welcome everyone here and anyone out there that may be watching. Today, the first item on the agenda will be a presentation by Ed Eichner from TMDL Solutions. And I'm not sure if Dr. Brian Howes is out there yet, from the School of Marine Science and Technology, the Coastal Systems Group. They work together and have been doing these pond management plans and assessments for the town of Orleans for a while now. And we welcome Mr. Eichner. The first thing I will do, and Dr. Howes, if he's, there he is. Hi, hi, Dr. Howes. Just so you know, because we have some new members, I'll just have us just introduce ourselves so you know who everyone is. And then I'll ask you to introduce and commence, starting with Valerie.
I think I'm the newest members still.
No, actually,
Okay, right.
You beat on that one.
you're both new this year, though, or
Next
last
one.
year.
Of about 5 months. A former editor at National Geographic, and of the real focus on conservation projects, which is why I looked into this when I came to town.
Good morning, Ed. Judith Bruce. You know me well. Good morning, Brian.
Brian's muted, I think. Judy Scanlon.
Hi, Rich Levy. I'm the yearling.
You're also our very capable clerk for he'll be doing the minutes.
Carol Etzold.
Carolyn Kennedy.
Bob Mullen. I'm an associate member of the committee.
And our newest member.
And Ed Hafner.
Oh, that's right, Ed's sitting over there, Ed Hafner, talking to the mic too, Ed.
Yeah, over here at the table.
All right, well, I welcome again our guest speakers today and look forward to the presentation on the Baker Pond Management Plan and Diagnostic Assessment. It's the draft final report. I will mention for anyone out there who is interested, the copy of that report is on the town website. You will go to the town website and then choose boards and committees, go to the Marine and Freshwater Quality Committee, and you should see the document on the left side of the page. All right, thank you very much and welcome.
Excuse me,
What?
Judy, is it possible for them to turn that screen on as well? So for those of us who are sitting on this side of the room, if
I
we
would
want
love to, but there's no power.
No
Okay,
power, all right.
So that's why I set up.
Answered, thank you.
I set up some tables for those of us that are right in front of the screen, so I'm going to move down there. You want to turn off these
I'm good
lights?
for the screen. It's
Yep.
just hard to see the people behind me, but that's okay.
Yep.
All right,
A couple of us are going to move, but thank you, Ed.
you ready?
Yes, I am, I apologize.
All right. Thank you very much for that introduction, and hello to all. We're going to talk about the Baker Pond Management Plan, which includes the diagnostic assessment. I got your comments last night from Judy, so look through that a little bit. Haven't had a real chance to digest it, but we're going to talk, I think I'll start off with sort of the take-home. Baker Pond is impaired. It's impaired differently than any of the other ponds that we've looked at. And in that difference, I think there's going to be some discussions about how you want to sort of tackle management of it. So, going to talk, we take a step back and we talk about where we started in this. 2016, 2017, we did a review of all of the available water quality data that is out there for the ponds in Orleans. Having worked in other towns, I will say you have got a whole lot more data than most other towns. And so that provides, I think, a bigger understanding of what's going on with these ponds and a much better understanding of their trajectory, how they're changing as time goes along. At that point, when we did that review, there was a lot of discussion about, well, what do we want to do in terms of management plans? Which ponds do we want to target? And you can see they were targeted Uncle Harvey's, Pilgrim, Crystal, and then Baker's. The first three, the management plans are done. And as a matter of fact, Uncle Harvey's, the implementation of that management plan with the alum treatment was done this past summer, which actually, to date, looks really good. It went through the summer, had really good clarity, didn't have any algal blooms, had DO almost all the way down to the bottom that met state standards. So at this point, looks like a very, very good outcome. The key findings in looking through all of that available data at that point were that all ponds were impaired. We needed to fill in some data gaps if we move through management to sort of put the water quality data that you all have collected into context, to understand why we see what we see when we look at the water column. And that we really needed to look at each pond individually because there were characteristics of each pond that were important to understand when we put all this together. And that's what we have done for Uncle Harvey's, for Crystal, for Pilgrim, and now we have done for Baker. So Baker is a combination, well, I call it the Baker Pond Management Plan. It includes within it a diagnostic assessment. A diagnostic assessment is coming up with an understanding of how the ecosystem works. What are the drivers that create the impairments that you see in the system, why you see the water quality concentrations that you see in the water column, how the overall system works. So then, once we have a basic understanding of that, then we can move on to discussion about what management options might be out there. So that's the basic. We went through, just as we've done on the other ponds, looked at phytoplankton, looked at continuous water quality. In this particular case, we had direct stormwater runoff, looked at bathymetry, rooted plants, the mussels, collected sediment cores, measured what conditions created phosphorus being regenerated off the bottom, put all that information together in the nutrient budgets and looked at the water budget, where the water comes from, where it heads out. And then we went through and looked at what particular goals we might want for this system, what sort of options we might want to look at in terms of making those goals, and then come up with a summary and a recommended plan. And that's everything that you've got in the draft at this point. So this is Baker Pond. This is Route 6 right over here. I hope you can see this cursor that I'm moving back and forth. This yellow line is the town line. So over on this side is Brewster. Over on this side is Orleans. This is Baker Pond Road that comes right down here. If you go all the way up there, you'll run into 6A. It's a great pond, which means it's over 10 acres. That makes it a water of the Commonwealth of Massachusetts. It has a boat ramp or a public beach with sort of an informal boat ramp. Doesn't have any constructive features. You could just drive across the beach to go into the pond. That's right over on this side over here. It's about 20 meters deep. And that's sort of the context of where we started with things. So we started to look by looking at some of the measures of what's going on in the water column. Whoa, what is that doing? Careful using the cursor. So the clarity in the pond, actually we have clarity, this is from 2001 through 2020. The clarity actually was improving in the pond up until around 2009, between 2009 and 2011. And then it's been declining since then. This is a lot of data. Generally, we don't have that amount of data when we look at ponds, but it's interesting that there was actually this improvement. It's unclear at this point why there was this improvement, but I guess the important part in terms of management is since 2012, the line is going down. Now, when we looked at 2019, the summer where we collected the data gap information, the SECI clarity was pretty stable. Bounced around between about 6 and 7. That's this blue line here. The average is this red line. So it was a little bit below average, but it was well within the max and the mins. This is the max and this is the min. Relatively stable. So actually 2019, one of the things that we found when we started to look through the data that was collected in 2019 was 2019 looked to be a pretty good year for Baker Pond. And that's sort of one of the things that Baker Pond has is a large variability. Some years it's not so good, some years it is very good. So temperature stratification, temperature readings through the water column show that this pond regularly stratifies. That means during the summertime, it's going to create 2 separate layers. There's going to be an upper warm, well-mixed, mixed by the atmosphere, winds going across the surface. It's going to keep it pretty warm. And there's going to be a bottom layer that's going to be isolated from the atmosphere that's going to stay cold. This is the average by month. And I'm trying to see if I can see here. This is April right here, which is pretty, it's got a little bit of a bend, a little bit colder on average. It's probably because most of the April readings are late in April. May, pretty well mixed all the way down. So same temperature all the way down to about 12 before it starts to get cold. And then as you march through the months, there's June, July, where's July? There's July, August. It gets warmer and warmer and warmer in those upper waters, but you notice there's a bend down to the deeper waters. They stay relatively constant, so they stay cold. This 20, there's a line here at 20 degrees. That is the maximum temperature that the state considers for a cold water fishery. So Baker Pond, one of its natural features is that it is a cold water fishery. If you had adequate dissolved oxygen all year round in this bottom water, you could have trout throughout the year. When we looked at, I'll get this thing popping up again. That was dumb. If we look at 2019, we sort of see a similar pattern, warming through the summer, but the bottom stays cold. So this layering is a regular part of the way the water column works in Baker Pond. The take-home in terms of looking at dissolved oxygen, there's a couple of take-homes. One is that the bottom regularly has hypoxia, and in some cases has anoxia. Hypoxia is just a loss of oxygen relative to the atmospheric equilibrium, so less than 100% saturation. Anoxia is going to be down below 1 milligram per liter. So that cold water fishery, that cold water layer down there, actually loses oxygen. So in most cases, you are not going to be able to sustain a trout fishery in this pond because you don't have enough oxygen. Trout are going to be driven out of that bottom layer. On here is the state regulatory minimum, which is 6 milligrams per liter. And you can see that bottom waters, once we get into, on average, I think it's June-ish. Yeah, green is June. You're down below that number. So June, all the way through the summer, you don't have adequate oxygen, at least as far as the DEP regulations are considered. One of the other things is that you see this as sort of it's at 8 and then it bulges up to 10. That bulge is supersaturation. It's oxygen above equilibrium with the atmosphere, so it's above 100, and in this case above 105. That is a function that you usually find in ponds that are impaired. You have phytoplankton that are hanging out right at that layer, the bottom of the warm mixed, well-mixed layer. Got enough light, they're able to suck up the phosphorus that's being generated out of the bottom sediments, so they do a lot of phytoplankton, and you get this bulge. And you can see this bulge is characteristic, one of the characteristics of the water column DO profiles throughout the summer. Saw the same thing in 2019. What you would expect with those kinds of deep impairments occurring is that we see total phosphorus that's being driven out of the sediments. And you can see in general that in this case, this is total phosphorus, 0 to 70, depth of the pond. In the upper layers of the pond, this is 2019, April through October profiles and measurements of total phosphorus. The upper portions of the pond are below the ecoregion standard, which is this 10 micrograms per liter. So what that's saying is that upper portions of the pond, that upper well-mixed layer, generally are in pretty good condition during 2019. It's once you get down to about that 9 meters, which is where you'd see that bulge, that you're starting to see the impacts of phosphorus coming off of the bottom sediments. It gets more extreme the further into summer that you go. So this is that long tail. This is actually, I think, October is this really far high concentrations at the deepest waters. But you can see it's happening back into, I think, June. Chlorophyll, not surprising, you also see, again, an ecoregion threshold is this red line. Shallow, pretty good conditions early in the year, but as it goes into the summer, you're starting to see more chlorophyll above the line, above the ecoregion threshold, and then you're seeing greater concentrations deeper. Some of that, like this one, is due to an active phytoplankton population. These deeper ones are these deeper ones down here are the transfer of chlorophyll down to the bottom. Transfer of phosphorus and carbon and everything else that ends up in the bottom of the sediments. We installed a continuous, a number of continuous sensors on an array at 16 meters in depth in the pond. This was done as part of the looking at the phytoplankton to get an idea how the conditions change, because you go and you do these snapshots and you may do them every month, but conditions may change sufficiently within that 30 days that are ecologically meaningful. The blue here, this is June to October. This blue is the DO at 16 meters. Starting in June, you're above that 6 milligram per liter line. Get to about June 21st and you cross that line and you've got it just declines in a pretty straightforward fashion throughout the summer. It gets anaerobic in August 24th, which is right about here, which means it dropped below 1 milligram per liter. The thing is, this activation, what I said in August, you get this anoxic concentration down here. That starts the cycle of releasing phosphorus from the sediments. Now, This is at 16 meters. Below that level, it's going to be anaerobic before that. What we saw in some of the profiles, historical profiles that were done was that the level of low dissolved oxygen actually was higher in the water column. If it is higher in the water column, that means you're activating more sediments to release phosphorus. So depending on where that is, you can have lots of phosphorus released or you can have less phosphorus released. It depends on what level it's at, when it occurs, how long it lasts. So we looked at the phytoplankton, and in general, levels were really low, but there is sort of a warning sign in the midst of all of this. These are the different classes, cells per milliliter. This is the warning. This is bright green is the blue-greens. In July, this is actually in 2021 because we had some problems with the samples in 2019, but 2021, blue-greens were the dominant species in July. By August, it was the greens, but conditions were such that the blue-greens can become dominant. Are they a problem at this level? No. Are blue-greens present in most phytoplankton populations? Yes. They're almost always there. The question is, do they become dominant? Do you get the kinds of blooms? Do you get the scums or mats that create visual kinds of concerns about what's going on in the pond? Mass Department of Public Health has a cell count level of 70,000 cells per milliliter. As if you hit that, they want you to close down the pond. The max in this case was just under 40 cells per milliliter. So you're well under those levels, but blue-greens, there are conditions that favor blue-greens that occur. To me, this says that if you get lots of phosphorus inputs, say that you get a number of days where there isn't wind and it's very cloudy and you don't have the phytoplankton adding oxygen, you're going to get low oxygen events. More of the sediments are going to be exposed. You're going to get lots of phosphorus in. That kind of series of events creates the conditions that you're going to get more blue-greens, and you'll get a bloom. Long-term, looking at the data that is available, Baker Pond is headed in the wrong direction. Total phosphorus is going up. Total nitrogen is relatively stable. To me, that says that there's really doesn't tend to be a whole lot of additional development in the watershed, but there's something going on, either breakthrough from the watershed in terms of phosphorus, or there are conditions in the pond that are slowly changing to facilitate more phosphorus being added from the sediments. Average late summer, and this is August and September, late summer shallow total phosphorus has doubled in the last 20 years. Right now, you're sort of teetering on the edge of the regional threshold of 10 micrograms per liter. That's where you're out here. Now, you'll see there's a lot of wiggle in this data, but it sort of gives the indication that you're headed towards worse conditions. Comparison of phosphorus and nitrogen, definitely phosphorus is the key in terms of management. This is any different than you've seen in any of the other freshwater ponds around. So that's all the looking at the water column. Now we've got to try to put all of that information into context about where are the phosphorus sources, where is the water coming in that's getting into the pond. Let's look at the relative magnitude of each source and what could potentially be done in terms of management to get this pond back to unimpaired conditions. So this is the watershed. There's Baker Pond right here. This is watershed that was delineated based on the U.S. Geological Survey groundwater model. It's the one that was done, well, it's both Pleasant Bay and Town Cove come into this modeling. On the south side here, it's Pleasant Bay. On the north side, it's Town Cove. So groundwater flowing out of Baker Pond on this side, and this portion of the shoreline is actually going to Town Cove. Down here, it's going to Crystal Lake, which eventually is ending up in Pleasant Bay. But upgrading it, you're also seeing all these other, so the top of the groundwater divide, the regional groundwater divide is over here. Water flows into Ruth, Cliff, Little Cliff, Higgins, and then eventually into Baker. Groundwater, of course, is the primary source of water that's heading into this pond. We looked at precipitation on the surface. We looked at imported water that's brought in from public water supplies and discharged through the septic systems in the watershed. We looked at stormwater. There's direct stormwater that's actually occurs on the down gradient side of the pond. So on this side of the pond, flowing back into the pond while groundwater's heading away from the pond. We did a bathymetry, which actually, this is tens of thousands of data points. It actually came out relatively close to when town volunteers, I think it was you, Carolyn, were out there with a plunker doing stuff, and we actually interpreted that data, but the volume came out to be pretty close to the same volume. We then looked at the watershed phosphorus inputs, went through, looked at all of the, just as we've done on the other ones. Geez Louise. Looked at all of the properties, looked at Board of Health records to find out where the leach fields were, how old they were, how old the houses are, and sort of track to see, are we within a number of years, has the phosphorus from these septic systems reached the pond or not?
I'm sorry, is it okay if I interrupt, or do you want me not to?
Can it wait?
Anything can wait.
Okay.
Forgive me, carry on.
All right, so anything in these green parcels right here, those are added, their septic systems are adding phosphorus to the pond right now. Anything in the gray here, these houses have septic systems, but they are not yet. That's because phosphorus is traveling very slowly to get to the pond. Phosphorus in the subsurface, in the aquifer system, tends to bind to the iron that coats the sand particles. You have to use up all of those binding sites before phosphorus can move beyond that site. So it takes a while to use up all those binding sites in between the septic system and the edge of the pond, and you've got to use those all up before you get breakthrough into the pond. So 10 of the 13 properties upgrading are adding phosphorus to the pond right now. One of the things that we found is that all of the houses, runoff off of all of those houses, is adding phosphorus to the pond as it stands right now. They've all been there long enough. They're old enough. We looked at direct stormwater discharge. There are a number of catch basins. I think this is Hinkle Road right here, that are along here that discharge some of the runoff off of this road, but they are not direct discharge of water. That's what we looked at when we looked at this section right here in pink of Baker's Pond Road. Whoops. And what we have is, here's Baker's Pond Road right here. There's a series of catch basins, which in this picture are underwater, that collect water as it flows all the way down from the north towards, down the road to these sections. If these catch basins overflow, then water comes out of this corrugated aluminum pipe right here and flows down this asphalt spillway to discharge into the pond. What we found was this doesn't happen very frequently. It only happens during really big storms or very intense storms. So one of these storms that we looked at, we were out there, it got 1/4 inch in an hour and a half. That's a very intense storm. That actually had discharge. We were out there, I think it was the one that was almost 1/2 inch, did not get discharged because it was spread out over a longer period of time. You'll notice in these pictures there's also this head wall here with the pipe. There appears as though there used to be a system that used to flow from Route 6, which is up here, off of that and then discharge into this head wall and then down this spillway. There was no evidence in any of our trips out there that there's any water that's coming out of that. They've actually gone through and redesigned the stormwater on Route 6.
And there used to be a rest area there on the Mid-Cape
Yeah.
years ago.
But that was all redesigned and fixed when they did the repaving a couple years
Right.
ago.
So we went through and we looked at the sediments. We went out and collected a number of sediment cores. You can see them on the map here. There's 8 of them at shallow and deep locations to sort of, and those sediment cores are then incubated in such a way that we measure how much phosphorus is coming off of those sediments under aerobic conditions, how much is coming off under anaerobic conditions, and within the anaerobic conditions there's what we call the chemical release phase, which is when the iron phosphorus bonds break, and typically that's a large release. That's in this particular graphic, it's the orange. So you can see that it's a big deal in terms of what happens with the pond. What we found was that the shallow sediments in general, under aerobic conditions, are retaining phosphorus. That's these blue, I think C4 through C8 are all shallow. All of them are above that 9-meter sort of bottom of the epilimnion, that upper well mix layer. They're negative here in this graphic, so they're actually sucking up phosphorus. So there's a lot of phosphorus. Sort of the take home on this is there's a lot of phosphorus that is being taken into the sediments right now, as long as those sediments remain aerobic. Once they become anaerobic, that orange, that breaking of the iron phosphorus bonds, you start to get phosphorus release. If anaerobic conditions are sustained after you've broken all of those bonds and released all of that phosphorus, there continues to be phosphorus that's released. That's this gray, and that's just straight anaerobic release of the phosphorus. One of the things that we learned was when we did this incubation that the chemical release, that breaking of the iron phosphorus bonds, did not occur until 18 days after anaerobic conditions were begun. In large part, that's because there's a lot of nitrate that's in the sediments. So the bacteria are taking the oxygen off of the nitrates before they are actually tackling the iron and phosphorus bonds. It's energetically favorable to them to do it that way. That's why they do it that way. It took 47 days to completely get through the orange, the chemical release phase. Now, why do I tell you those lengths of time? Because they're sort of important, because when we look at the dissolved oxygen concentrations in the bottom of the pond, if it takes 18 days to get to that chemical release phase, you're not releasing phosphorus from the pond. From the pond sediments until you've gotten to that end of that 18 days. So you need to have those anaerobic conditions for 18 days before you start to do that. At 47 days, you've got to get, you know, that's a long time. That's a month and a half to get to that point. So taking that information and tying it to what we actually see in terms of the dissolved oxygen gives us a better sense of how much phosphorus is coming off of the sediments. One of the things I will tell you is that when we looked at these cores is that there were different characteristics in a lot of them. We saw this, I don't think I have the ponds, the plants in here, but we did see sort of a patchiness throughout the bottom. There are different characteristics that suggest that depending on where you are in the pond, there may be different kinds of conditions. And that it may vary from one spot to 10 meters away from that spot. So we took all of that information and we looked at developing a budget of where phosphorus comes from in the spring, before the sediments become really active, where everything's well oxygenated, and really the only source is going to be what's coming in from the watershed and that stormwater addition. And wastewater, septic systems are 3/4 of that phosphorus budget. Now, when we go to the summer and those bottom sediments become activated because things get anaerobic, it gets pretty close. It's pretty much the same percentage. The sediments are about 41 on average. Wastewater is about 45. So when thinking about management, it sort of presents you with this, okay, if we're going to do it on the basis of just looking at the spring, we'd probably just want to tackle the wastewater. If we want to look at it in terms of just looking at the summer, we probably want to think about, is there some way that we can tackle both what's going on with the sediments and what's going on with the wastewater. Personally, when I look at this, I say, well, the primary source of what you're seeing in the sediments is the wastewater from the watershed. Probably should tackle the wastewater from the watershed. But I know that becomes somewhat of an issue. Lots of discussion in the past, especially Crystal and Pilgrim, about moving down that path. So the other thing that we found when we looked at a lot of these budgets in the water column of mass is that sediments appear to become the biggest source once the water column mass becomes over 10.6 kilograms. And so that occurs in about 23 of the available water column total phosphorus estimates, 23% of the water column estimates. There's about, I think, 70 water column estimates that are available. Like I said, you guys have a lot of data. So that seems to be a threshold that, you know, once you cross that, the water quality conditions are that the sediments become the primary source in the overall budget. So, summary, you have clarity problems, you have significant increases in terms of the trend for the phosphorus concentration, you have regular summer hypoxia and anoxia, and the mass that you're seeing in the water column, I didn't put that up, but the mass that you're seeing in the water column is actually going up as well. 2019 was actually a pretty good year. You had some hypoxia and anoxia. Shallow conditions, however, total phosphorus was generally acceptable. The deep, of course, was impacted by sediment additions. Chlorophyll, on the other hand, in the shallow waters was above the ecoregion threshold. On the regulatory side of things, you definitely meet the criteria to be classified as impaired in terms of state surface water standards. So I think I said, well, Anything I missed? I think this is sort of a recap of what I said. This was, like I said, I did this late at night, so. Wastewater, one of the things that we were trying to get to was what appears to be acceptable. When conditions are acceptable in the pond, how much total phosphorus mass is in the pond? And that appears to be about 8.2 or less. So when you have 8.2 in the overall water column, so looking at the phosphorus mass in the bottom with the sediment impacts and how much is in the upper waters, it's about 8.2. So that's a potential TMDL target. If and whenever you might get to that point or be forced to go to that point. So in terms of looking at management goals, as I said, 8.2 at this point is perspective target goal for total phosphorus. You need to address the impairments of the state surface water standards. And one of the things that I've recommended on all of them at this point is don't get into TMDL land, at least as far as the state is concerned, until you actually have something that attains your water quality goals. So you can say, this is what we implemented, this is what we find acceptable. State, we'd like your blessing to have this on your list, because in large part, you don't want the state to come down prescriptively and tell you this is what you need to do. You want to be the ones in control of how that works out. So, now I'm going to start to talk about the management plan side of things. That was sort of the understanding of the system that we have based on the data that we have at this point. We went through and looked at a whole bunch of different options. Obviously, at this point, you know, looking at the data, we're really looking at the watershed, how much phosphorus is coming in from the watershed, and then aspects of looking, do you want to go down the sediment control side of things? As I said, the majority of the source in the spring is really the watershed. So if you tackle the watershed over a period of time, you're eventually going to tackle the sediments too. The question is, should you do something in the interim, depending on how long it's going to take to address the watershed side of things? So wastewater phosphorus reductions in the watershed. In the pond, your options are the same ones that are pretty much to come up at this point for the other ponds. Hypolimnetic aeration, that's only aeration of that bottom layer to maintain that cold water layer, dredging of the sediments, or an alum treatment. So we looked at the various options and what they might mean. Sewering is going to be 100% removal of the phosphorus from the septic systems. You can tackle the 10 or 13 houses. If you run the sewer line, you're probably going to tackle everybody that's there. Questions really come into this, you know, town line thing. If you run a sewer line down to here, do you try to pick up the Brewster properties? How does that work? It's about a mile and a half, just following the road layout, up to the overland road where the treatment plant's going in right now. Are there other options? Probably. You probably have to cost them out, whether you might want to think about doing some sort of satellite thing, or if Brewster might want to get into some discussions about that. There are other options, but if you do the sewering thing, you meet the standards that we've sort of hit. You hit the target. If the sediment loads continue to be a source, you're not going to be hitting the target about 7% of the time. But like I said, over a period of time, if you remove that phosphorus source, you're going to start to clean up the sediments, because they're going to have less phosphorus coming in. That means they're going to have less phosphorus available to release back into the water column. You can go down the path of alternative septic systems. These are ones that are out there on the market for phosphorus removal in particular. They're in what's called the piloting system as far as DEP is concerned, which is sort of, they're past experimental, but they're still somewhat experimental. DEP only allows 15 of them to be installed. That's statewide. They require monitoring and media needs to be changed, et cetera, et cetera. If the town decided to go down this path, it would probably, yikes.
It's a timer.
It's moving around that
It's on a
cursor.
timer.
If you decided to go down this path, it would probably be, from a management perspective, better if you just did one technology rather than a whole bunch of technologies in terms of becoming familiar with them and managing them and everything else. You also get into the potential that, you know, it might be a town kind of management of these systems rather than individuals. But those are things to discuss. Anything else? All right, so those are the tackling the watershed. Then there are addressing the sediments, and as I said, this is less of the impact. If we look back to those pies, 75% of in the spring was really from the waste from the watershed. Hypolimnitic aeration is just taking you run oxygen down to some sort of structure that redistributes the oxygen into the lower portion of the water column, the hypolimnion, and keeps it in there. There are a whole bunch of issues about wanting to try to make sure that it stays in there, that you don't warm it up, so that you don't break down the cold water, warm water separation. You would have to run this basically forever. May to October, or whenever turnover is going to occur. Generally, all of these, for dealing with the sediments, work best when phosphorus regeneration is clearly the largest source of phosphorus to the water column. Among your ponds, Uncle Harvey's is the only one that's really been that way. As I said, hypolimnitic aeration, you need to run it forever. Alum, you would do a treatment. It's going to last for a while until the water, if you don't do something about the watershed's going to keep adding phosphorus in. Eventually, you're going to get to the point where you're going to have to do another alum treatment because it's going to create the same sort of conditions. You know, probably good for a decade or so, depending on how well it performs. Dredging, same sort of situation. You're taking out material, taking out the sediments, taking out the source of phosphorus. There's technological issues with trying to come up with something big enough that's going to be able to reach the bottom of the pond, but it's going to be the same sort